We're now going to begin talking about one of the most advanced topics that we'll cover in this course. That topic is called backtracking. Now, backtracking is a recursive algorithm where we essentially try to solve some sort of puzzle by a technique which is best described as brute force. Essentially, what we want to do is try every possible direction or every possible move that we can make in the puzzle, and if we ever reach the solution, then we know that we're doing the right thing and we say yay. However, if we ever get to a path which leads down to a dead end, then we essentially say, okay, this was not the right path to go down. So now let's try going down some other path, taking a different left turn somewhere up ahead or previous. So the first backtracking solution that we're going to look at is mazesolver. Now to give you an idea, mazesolver is essentially the problem where we have this maze, and we'll talk about the representations of this maze later. But essentially, we start at the top left, and we want to get to the bottom right. And we need to basically figure out how. And so, if you were let's say that you were in the maze and you had no other option. You didn't know how to get to the bottom. The simplest way that you could do it is essentially say, okay, I'm always going to try, when I'm in a given node, I'm going to try going up, then I'm going to try going down, then I'll try going left, and then I'll try going right. So up, down, left, right. When I go to that next node, if I can't because it's off the board, then don't go there. If I can't because there's no connection, then don't go there. And if I've already visited it, then don't go there because I don't want to go backwards. So let's say we're up here. So I'm going to try going up, and I can't. So then I try going down, so I can. Now, once again, I try going up. I already went there, so I don't. I try going down. I can't because there's no connection. Then I try going left. I can't because it's off the board, so then I try going right, and I make it. In this way, I try going up, I can't, I go down. Once again, I go down, and once again, I go down. Now, think about what happens at this place. I try going up, I can't. I try going down, I can't. I try going left, I can't, and I try going right, and I can't. So essentially, I've tried all four directions from this node, and none of them led to the right path, right? I wasn't able to keep solving it. So then I basically return and say to the person that I stepped from, to the previous node, which is this one, that this isn't the right path to go down. And this is what we call the backtrack. So now, this node had tried going up, it tried going down didn't work, so now it'll try going left. So it tries going left, then I go up. Once again, this is a dead end, so I backtrack. This node tries going down. It's a dead end, so it backtracks. And then this guy tries going left, it can't. Tries going right, it can't. So it backtracks. So now this node has tried going up, down, left. It'll try going right, it won't work. So then it will backtrack. And in this way, we keep going down. So essentially the idea of backtracking is that we keep going until we reach a dead end, or if we ever reach the solution. And then once we reach the solution, we basically know that we're done. So then we propagate all the way back and say that we've reached the end and it works. So just to see if that was the solution, I press S, and that's it. So this is the basic intuition behind a backtracking algorithm for solving a maze. So let's actually look at the code. So this is the key excerpt for mazesolver, and it's the solve function. And what the solve function does is, given a specific row and a specific column, it basically says, can I solve it from this given location? That's how we think about things recursively. When we think about backtracking, it's like, okay, I'm trying to solve it from this row and this column. Now, in order to know if I can solve it from this row and this column, let me try and take a step in one direction and solve it from there. Now, we have a list or a set of nodes we've already visited, because remember, we don't want to go to something we visited already. So what we're going to say is that if the row and column we're at is already visited, then return false, because that means that we can't solve it in this direction. We've already visited it. Otherwise, we're going to visit this node, so add it to our visited set. Now, if the row and the call is equal to the target row and call, that means we've reached the end of the row, at the end of the maze. This is our base case. The base case in a backtracking problem is essentially when you get to the end, because now we're done. So we can return true and say that we solved it, because if I asked you to solve a maze from the end, then you would say like, okay, I'm done. Now, if we aren't done, we basically get to the recursive case. So in backtracking, you're always going to essentially just loop over all possible directions that you could make a move. So from a given node, I can go in 4 directions: north, south, east, and west. So I say for those directions, loop over them. Now I check, is it valid to move in that direction? So it's only going to be valid if it's on the board and if it's also there's a connection between them. And so if this is a valid move, then I'm basically going to say, okay, let me try to solve it in that direction. So I add row plus drow and call plus decall. Now, if solve returns true, that means that I went in that direction and I was able to solve it. If I could solve it from there, and I can go from where I am to that location, then that means I can solve it from my current location. So then I return true. However, if solve returns false, that means that going in that direction leads down to a path that does not end up in a solution. So I essentially just say, okay, loop to the next direction and try solving it again. Now, remember how in the example before, we got to a place where going up, down, east, and west, none of those led to a solution? So that means I would exit out of this for loop. This means that essentially I am not part of the solution. So I remove myself from the solution set, which in this case is the visited set, because I know that if I cannot solve it from any of the 4 directions where I currently am, then that means that I must not be part of the solution. So then I return false, because if I try to solve it from this row and this column, no matter which direction I go, I cannot solve it. And in this way, it'll return the false back up to whoever called it, and that caller will basically try a different direction. Now, if we keep going down and we keep solving and eventually we get down to our base case, this will return true, which will then be called back in this if statement, and that'll return true. And it'll keep propagating backwards until the original caller, solve of row equals 0, call equals 0, will say, oh cool, I can solve the maze from this location. So in this way, we essentially are backtracking, because we try all the directions, and if we solve it in one direction, that means that we can solve it, so we return true. And if we can't solve it in all 4 directions, then essentially that means that we can't solve it from where we are, so we return false. This is the essence of backtracking, and we will see this in the next problem as well as on the homeworks.